As what we are going to describe through the schematic layouts for the irrigation system, we have to discuss the locating of valves on the main lines. Valves should be accessible for maintenance and servicing. The valves or the valve box should be located where they will not interfere with normal traffic or use of the area. Where possible, the valve serving a group of sprinklers should be at the center of the group to balance the flow rate and the side of the lateral pipes. Irrigation systems connected to potable water supply line shall be connected via vacuum breaker method or a backflow preventing device. If we check the below figures, we will recognize that the valve box that we are talking about, it's recommended to have that valve box in the green area itself. This valve box will include an isolating valve, which is manually controlled, and the solenoid valve, which is controlled automatically with the controller of the irrigation. If we check the indicated sketches about the valve box configuration, we will recognize that it's a plastic box with a plastic cover, so it should be located in the green area away from any heavy traffic that could cause fracture to the box. We can have two boxes, one box for the isolating valve which is manually controlled, and this valve or this branch is connected to the main line coming from the pumps, and we can call the main line as a primary line, while for the branch out pipe we can call it as a secondary line. Secondary line are commonly containing an isolating valve which is manually controlled, PVC type, and connected to the line itself. And then we can add another box to occupy the solenoid valve. Upstream the solenoid valve, we have to add a strainer or isolating strainer to filter any particulates that could cause any blockage through the solenoid valve. Both valve boxes are located through the green areas itself. You will commonly find this arrangement for every feeding or every supply line for a certain green area. So if we had three green areas, one covered by sprinkler and one covered by palm trees and one covered by shrubs, you will find one of these arrangement for each type. Controllers. Traditional controllers can carry up to 48 valves, and each valve is connected individually, which are wasting too much cables. While in case we are using a decoder controller, it's much more smarter and carry up to 200 valves, and one cable can connect all valves, each valve with decoder for indication at the panel. We can summarize this type of panel as an addressable panel, which is recognizing each valve specifically with a certain number. Log sheet shall be submitted to the operator including valves numbering and timing, as the adjustment of the controller and the performance and the schedule of irrigation is a process that shall be done with full coordination with the operator of the landscape area. So, as a summary, we can say that the selection of the panel type from a traditional type to a decoder type is commonly depending on the number of the connected devices or number of valves. So we can say that for small projects, the traditional controllers are commonly used. Even if we need more than one controller, we can define the project for more than one controller to have that each panel are supporting 48 valves. While for large project, we were recommending that you go directly for the decoder controller, as you will need one controller locating for a certain room under the full supervision for the plantation operator to be monitored, to be scheduled, and to be followed. One of the most important systems that I will recommend through large landscape irrigation system is the flow metering and leakage control or monitoring system. In this system, master valve and flow meter are used on the main irrigation feeding line and connected to the irrigation panel for leakage detection in the main pipes. And for checking the branches, it opens each solenoid valve one by one to find the leakage through flow meter readings. So if we have a pump and through the main valve transferring a flow rate from a certain point or the primary point to another point which are feeding the sprinkler or the irrigation device, both points or both flow meters are connected to the panel. If the panel are monitoring a difference in flow rate between point 2 and point 1, like we say that if Q2 is less than Q1, then the panel will notify you that there is an anticipated leakage through this line. So you have to follow up and detect the leakage point. So this system can be added as well for each branch. So if you have a certain quantity that you are scheduling the panel for it, and this branch will have a number or a nomination, and this nomination will reflect a certain flow rate. If this flow rate are not the same flow rate or the actual flow rate measured through the water flow meter, you can say that this point have an anticipated leakage. So accordingly, you have to track this branch and go and dig for this branch to inspect if it's well or there is an actual leakage at here.